Do you think the decimal is my favorite form of answer? No, because it's not precise, right? So just keep in mind, even though you were supposed to find the decimal, technically, in my mind, that was just a check. Does that make sense? That was just a check. You can check in the back of the book and make sure that what you got, even if it might be in a different form, would simplify to be the same thing as what they got. Does that make sense? Because just a few of you are like, whatever. If I can use my calculator on this test, who's going to solve anything? Psh, not me. Yeah, it's not going to work like that. But you could do the decimals and homework so that you could check. Okay? All right, so number 12. Yes, 0.01 is great, but 1 over 100, way better. Number 16. You were supposed to set the two equal to each other. That's how you find the intersection. A few of you might have forgotten that. The intersection is what point they share. Set them equal. 3 to the both sides, x equals 9. Wait, how'd they get a point? Oh, that's right. The y value is 2. So 9, 2. Number 24. Okay, the decimal. And if you found the decimal, or if you need to plug yours into your calculator real quick, the decimal is 0.554. You can write that down even in your red pen and check it later. 0.554. But what's the best form? ln of 0.10 or ln of 1/10 all over 3 ln of 4. You could have also made it ln of 4 to the 3. That would have been exciting, ln of 64, but either way. Good?
I put log because I see that.
Or you could do log too, because common log you can do 10.
1 is 10 to the negative 1, but I still got it wrong.
You still got it wrong?
Yeah.
Did you get over 3 log 4?
I got log, okay, so
Negative
3
1.
t log of 4 equals negative 1. Then I put the negative 1 to the other side.
Just the negative 1?
I mean the log 4 to the other side, so it's
Negative 1 over log 4?
Minus log of 4.
Oh, not minus, divide. Because it's times. Negative 3t times log 4.
Jeez, I confused the t with a plus.
Oh, does that make sense? There you go. It's easy to do. It's easy to do. That's why, if you guys notice on my notes, I always do the t with a little curl at the bottom, so I don't confuse it with a plus, because it's easy. It's easy to do. Now the next one, number 30. Final answer is, okay, 0.648 lets you know whether or not you got the right decimal. But negative 1/4 ln 3 over 40. Hey, why'd they use ln on this one? Yeah, there's an e. So ln for sure was the best. Luca did have a point, though, on this one. Since 0.10 is 1 over 10, log base 10 isn't a bad one to use. Log base 10 wouldn't be a bad one to use. Anyway, negative 1 over 4 ln of 3 over 40 is the other answer. Number next one, 36. Why'd they use ln? Because there were 2 different bases, right? We saw that yesterday in our examples. So then just use one of them. And ln's the easiest. Plus there's already an e, so he'll cancel out one side. Then do you see the distribution? Right? Get rid of that multiplication. Get all the x stuff on one side, all the non-x stuff on the other. Pull out the x, divide, and say, whatever, there he is. Some of you thought you could cancel out, but you're killing poor little kittens, because if you put them in parentheses, they do not match. Decimal will be 0.181. A couple more seconds. You can still see the answer right there. Do you have a question? Yeah. While Luca's looking real quick, can I just quickly go look at your notes? We had one like this though, right guys? Remember how we did all those examples yesterday? Let's see. Is that it? Nope. Is that it? Nope. Is that it? Nope. Is that it? Yes. Didn't we do one just like it? 2 different bases? We just used ln and went for it? How many of you guys used your notes at least once in homework last night? Whew, that's it? I mean, great job, those of you whose hands are raised, but those of you who didn't use your notes, how are you doing this? Maybe you're not, or you're geniuses. Either way, we got to be careful. The examples and the notes were there to help you, okay? Let's go back to homework. Oh, sorry, that's not the one we want. We want this one. Okay. Number 50. answer, e to the 10th plus 8. Who wants to get that decimal? Not me, but if you wanted to get the decimal, there you go. So e to the 10th plus 8. The key was probably doing e squaring both sides. You might got a little stuck, power to a power 5 squared. No, e to the 5th squared. You multiply. 5 times 2 is 10. Number 60. Final answer is 2. Oh, because factoring gives you 2 answers. I don't get it. I was preparing you yesterday, even though it was a horrible example, so it didn't actually apply. But remember, you get 2 answers, and what are you supposed to do with them? With logs, since the domain says only certain numbers?
Check if they work.
Yeah, check if they work, right? So when we factor, we check and see if they work. Plugging in a -3, negatives aren't allowed in those logarithms. So he's a no. They call him extraneous because the math says yes, but only because we ignored the logarithms for a while. But we have to, when we get to our final answers, remember, ooh, yeah, that's right, they're logs. The 2 is positive or makes everything positive, but -3 does not work. Only answer is 2. Number 78. E. If you really went to a decimal, go you. But E is the best answer, which is 2.7182, etc., etc., etc.
What are you graph? How would you graph it?
Oh,
Because
you need
it's
to graph
equals to 0. Yeah. You had to graph and verify the answer.
Oh, to verify. Remember 0 is just the intercept?
Yeah.
So you could have actually graphed the 1 minus ln of x over x squared, and then you could have found the x-intercept, and the x-intercept, if you found it in your calculator with the 0 function, should have been 1 comma, no, what am I doing? Y is equal to 0. 2.71828, etc., etc., 0. So if you had found it in your calculator, this would have been the x-intercept. Does that make sense? Alright, let's go look at those odds, because you were able to check those. You've seen the answers to the evens. They're taped. If you need to go back and look at them in more detail, find your mistakes, etc., you can. But I'm a little bit more concerned right this second with the odds that you could check. You could look at CalChat and or Slater. Hopefully they were right. And then you still got stuck on any odds.
73.
39, 73. Anything else?
55.
55, 73, 57,
I'll get there.
29. 29.
39.
Hold on. Any more questions? Okay, give me a second. Some of you do have participation points, and I would love to give you more, except I would also love to get some new people up who haven't gotten points yet. I don't really pay attention until we've done a few, and then I try to spread out the love just a little bit. Markers at the front. Remember, if you get one from this box, you put it back in this box. Wherever you go on the different whiteboards, just erase whatever's there. I don't need it. Just don't erase my assignment board. You guys looking to see any of the ones you can do? If you want to do at least one, raise your hand, and I'll call on you based on who has the least number of that. Jesse, what do you want?
I can do 29.
It's yours. Take it.
Okay, I don't know where the number is.
Come on up and grab a marker and start right away. Oh, wait, that's it? Sean wants to steal them all. Amanda, what do you want?
39.
39. Yours? Sean's ready, guys. He's ready to go. Anybody else want one? Luke and Sean are tied. I can give them. Sure you don't want one? Self-determined your participation. Alright. Luke and Sean, we'll try to get you on 2 different problems. What do you want, Luke?
57 for the W.
Okay. What do you want, Sean? Oh, was that it? You do another one?
I'll do 7.
Okay. He's grimacing a little bit, but we got it. 55! Come on. Come on, my honors kids. Come on. You got too much? If you can do it, though. No one else is taking it. Do you want it, Lisa? What is it again? 55? No one else is raising their hand?
I'm afraid I did it wrong for sure.
Alright, right now, people with participation points are Amanda, Luca, Sean, Nicole, Jesse, Lisette, and Brandon. The rest of you, I don't have one yet. We need to get you up to the boards at some point, so you need to be working on this homework. Maybe coming into math lab trying to get some questions answered, then you can rock it on the questions the next day, yeah? Maybe not a bad idea, so start thinking ahead. Start thinking ahead, and you can get you some time up at the board just to show what you did. What you do, what you know. You're just doing counting how many they got wrong, do they have? And then, yeah, like how many questions wrong, and then they got them all 10 out of 10. If they forgot something, minus 1/2. If they got a whole one, write the number, minus 1. That's calculus basic. And then this one. You can see our writing is in blue, you and me. Their writing should be different color. So as long as they see. Do the same thing as that. Each one. Yeah, 10 out of 10. Each one they don't show. They were supposed to do bonus too. Just make each one they don't show corrections on. Just make it -1. I don't want to ruin their score, but make it -1. Each one they don't show. Like she did this one, so don't take off for that one. But yeah, same thing for those 3. So -1.5, 8.5. Let me give you other pen. Ooh, here, you can write your number. Second, and then. Give me a sec. Alright, while they finish up, kiddos, let me go ahead and pass out your tests. Since I'm passing out your tests, that means corrections are coming, right? But you have a test first and foremost to prepare for, right? So our test is on Friday. This homework is technically not due till Thursday, but my strong advice is to do as much tonight as you can. And our chapter 2 corrections. No, that's our test. Let's go ahead and have them do Monday. Does that make sense? And we'll say Monday by the end of the day. So if it's something where you get stuck over the weekend, you didn't have time to get a lot of questions answered this week, you want to work on them a little bit this week so you know what. There we go. So you get a little bit of help before the weekend, but you still have some time on the weekend. If you have a few more questions, you can still come in after school on Monday. How about that? I'm not separating them, or I'm not putting them in like grade order or anything like that. I'm just quickly going through. Just highlight a few people. All right, come on down when you hear your name. Luca. Brandon. Karina. Ella. Those were all the ones over 100. So maybe like, I need some help, they can help you correct because they have basically nothing to do, or at least very few. The rest of you guys, there are other A's and it's all mixed up at this point, but those are just the ones over 100. Here we go. Amanda, come on down. Nicole, come on down. Kristen, come on down. Hannah, come on down. Melissa, come on down. Eris, come on down. Eric, come on down.
I got numbers 8 right.
Celeste, come on down. Jesse, come on down. Cosette, come on down. Lisa, come on down. Carrie,
Jesse,
Sean,
I'm telling you.
Lonnie. Oh, who's 5? What's his name?
Oh my.
All right. Okay. Okay. Real quick. To get 100 on your corrections, you have to correct anything you lost points on. Some of you might have been losing points because you're like, oh, I'll correct all the big ones and I'll forget the little ones. You lose a whole 1 out of 10 for any problem where you lost points that you don't correct, okay? So get these corrections down, figure out what went wrong, feel free to ask. You saw the ones over 100, but there were several others that did okay as well. I could help you, definitely. These corrections due by Monday.
Do we have to correct even the bonus ones?
No. Because technically you don't lose points on the bonus. It's not bad to review, but you don't have to.
I see, and I don't, I'm not sure if I did 57 right.
I'll check it out and get it.
All right, go ahead and put these away. Go ahead and put it in your pocket folder. Remember when you turn these in on Monday, you have to staple to the front. If you didn't lose any points anywhere, you just turn in a blank correction paper and say, "Who got 100 on my correction?" But you can still help others. So you might want to hold on to your test and that way you can help them with. Now, guys, real quick. Is it really helping someone if you just show them your work and you're like, here, copy this? It doesn't help them at all. Okay? You have to sit down and you have to explain it to them. Wait a minute, if you're sitting down and explaining something to someone, what could that kind of be considered? For some reason, some of you picked these up, and some of you are just kind of ignoring and leaving them out there. Remember when we talked about the tutoring thing this semester? Okay. For some reason, I don't think we officially passed these out. I have had people coming and just getting them because they have been tutoring, and the rest of you guys are like, I have been playing dumb. You have to stop doing that. But listen, if you need some help on your corrections, couldn't you sit down with someone else in the class and be like, hey, I need some help. I didn't do as well as you, or I don't understand this as well as you. Can you explain it to me? Question, is one person getting tutored? That counts on something they didn't feel very confident on. And is another person tutoring? That counts for them too. Could that be a cool thing, helping each other out and just sitting down doing some math? Where can you do that tutoring? Do you remember? In here. I can sign off. At Starbucks and take a selfie. Take a selfie. I almost said the wrong thing. And then you can fill out the off-campus tutoring form. It's on the website under HonorsPrecalc. Welcome announcement. There's like a tutoring info. Where else? In the library after school. In a study hall for a sport on a day. Just find someone on your team. There's probably someone who can do math. Hopefully one of my calculus kids. I think I have a calculus kid on almost every team. On every team. George is on football. Angela's on volleyball. There are others too. Like I have multiple. Laura's on tennis. Kara's on soccer. There's a few others. One's on soccer. A few others on football. So anyway, basketball. Yeah, Keithan's on there. And like you guys can help each other, right? So anyway, if you're in a study hall, have your coach sign off and be like, hey, yeah, they were helping each other. Sweet. Does that sound good? So there are multiple ways of doing it. It doesn't have to just be in my room. We're just gonna have you guys pass it around if you haven't gotten one yet. You just need to take it, read over, ask me questions. We'll take questions tomorrow if you have any. For some reason, I don't know, we just never passed around the whole room, so there we go. Kiddos. Those homework things on the board, I'm going to check them out as we get working on stuff today and make sure it looks good. You can take pictures of them on the way out the door. And we might at the very end of class see if you have any questions on what they did. But for right now, you guys get all your markers back in this box.
I didn't grab another box with this stuff on. When you say signatures of various.
If you use one out of the box, just put it back in the box. Here we go, section 3.5. We won't have a lot of time, but we have some. Esther, put it away.
Let's take a picture real quick.
Yeah. Get the door open. Where's my trash? That guy. Okay. Okay. Here we go. Here's the main idea. We're going to be reading stuff, and from the reading stuff, we got to pull out clues. Like, first of all, we got to pull out what we're supposed to use, and it's either going to be that's why it was all messed up. Like spacing is off. Oh well, we'll deal with it. We need to figure out the model to use. What's the model? Oh, it's just a snazzy way of saying equation. Identify the model to use. Whatever. It's the equation. Sometimes they give it to us. Sometimes they give wording that helps us make the equation ourselves. You guys know wording from before, like sum, difference, is, means, equals. We have our different variations. We have our now we have exponential and logarithms that might show up. But usually they'll give you an equation. You have to figure out what variables are in the equation. You have to know what each of them represents. What are they standing for? What are they talking about? Does the problem give you any clues about what they mean, how to find them, how to solve for them, etc.? And once you know what the variables are, looking for clues, you just have to figure out what do they give you. And carefully using legal math, plug and chug. Plug and chug meaning, figure out what they gave you, figure out where it's supposed to go, and then solve for whatever they want to know. Solve for whatever they don't know, or they aren't telling you, and figure out what it's supposed to be. The spacing is really annoying me. Give me a second. Okay. Is that it? Oh, we have some models we need to talk about. Okay, so remember, identify the proper model to use. State the equation, but if they don't give you an equation, we have to know what models are available to us to use. So starting off, numbers 1 and 2, you guys see the word exponential, right? Why aren't they saying exponential?
Hold up.
Exponential, they're both exponential, right? What's the difference between number 1 and number 2 in the titles? First one is exponential who? Growth. Second one is exponential decay. Okay, what's different about the graphs? Exponential growth, the graph as you go left to right is doing what? Increasing, going up. Growing. The one down below is doing what? Decreasing or decaying, going down, shrinking, getting less and less and less. Right? What's true about the power for the first one? Positive, showing growth. What's true about the power for the second one? Negative, showing decay. So there are 3 different ways of looking at all these. Just the wording, growth, decay, just the graph going up, going down, and just the equation, positive or negative. Now there is one special set of growth formulas. Compound interest. Compound interest is an exponential function. For n compoundings per year, A, what's A stand for? Oh, hold on, let's do a little key over here to the side. A stands for compound interest. A stands for the amount of the interest. Sometimes they use I. Some math people don't like to use I because I is the imaginary number, so they just kind of stay away from capital or lowercase. P is, you guys remember him? You've used him before. The original, right? You can say the principal, it means the original balance, the money you put in originally. R, rate. T, time. And the only one I didn't talk about was N, but N they tell you in the problem itself. How many times it's compounded per year. So if it says annually compounded, how many times per year? 1. Semi-annually. 2. Twice a year. Once halfway through the year, once at the end of the year. Monthly. 12. Does that make sense? Daily. Oh dear. 365. And continuously, well that's just awesome. He has his own formula. He depends on E. So we have exponential growth. It's an exponential function with a positive exponent. Exponential decay. Exponential function with a negative exponent. And then we have these special little compounding interest ones in between. You guys almost have them? You're getting the main idea. For the sketches, don't worry about getting super precise. You can just show the swoop up and the swoop down. I know the hard thing is in this section, just getting the models. Are we close?
What's principal?
Principal is the beginning amount.
Okay.
So it's like the beginning balance of the account. I think any statement that ends with there's no proof is probably true. Okay. Which one? For the graph, all you have to do is just swoop down. You don't need any particulars. NT. NT. The second one is RT. PERT. A equals PERT is continuous compounding. But not the shampoo. Maybe it's a soap. How about now? Okay. Oh! Okay, a couple more. But wait a minute, look at these. They're different. Focus, focus. They're different. They're different. Don't worry about the graphs in terms of the equation. Don't write the equation for the graph. Just show me the basic shape of the graph, okay? But if you look at both of these, aren't they still special types of exponential functions? They're funnier, they're weirder, they have extra stuff going on, but they're still special types of exponential functions. The first one is called Gaussian. I guess you could say Gaussian. That's kind of awkward. Gaussian. Just say Gaussian. Might be referred to as a bell curve. Ooh. Might have heard that before. Just a special type of exponential function. So technically you could write it as a e to the negative x minus b squared all over c. That's what it's showing. Just when there's like a division inside of power, sometimes it gets a little complicated for actually typing it. So they shortcut the process. Yeah, it's like all over c in the power. That helps. Now I do want you guys to go ahead and put these in parentheses for me, okay? And the reason I'm saying this is because you don't need to memorize these ones for any test or quiz, but if it's given to you, you do need to know how to plug into it and how to use it. It doesn't mean that you have to memorize it. Does that make sense, the parentheses? Okay. Uh-oh, I didn't put them on 1 and 2. Yeah, they're kind of important. But they're basically the same, just one has a positive exponent and one has a negative, so it's kind of just like one. Yeah.
Are you going to write anything under those? Like, should we...
No, you're good. There's stuff I could write, but it's more just seeing how problems use the equations. So we have the Gaussian, that's the bell curve. We have the logistic growth, and I could explain him a little bit better, but let's wait until we get a problem to see why this graph behaves the way he does. He's actually really, really practical. We almost there? You see this logistic one has a horizontal asymptote up here, right? And technically this one has a horizontal asymptote as well at 0. They just didn't show it. Okay. Oh, well, this doesn't look that crazy. Isn't it just kind of like the equations that we wrote before for transformed logarithms? Yeah, pretty close. Logarithmic. Might just be a number in front plus some sort of log. B times ln, b times the common log. You don't usually in equations see anything else because it's just a little bit harder to work with any log base 2 or 3 or 7 or whatever. Usually you either see ln or common log. I don't know if you guys necessarily need to stress about these graphs because we already have them written down. Common log is a little bit shrunk or a little bit compressed because he's a base 10. Natural log's a little bit higher. The higher the base, the more compressed the graph. That's okay, no big stress. Almost? Okay. You ready? Soon enough. Give a high five to everybody in your group. I don't have a banner for you to run through and get come by and then hurt all over. But here we go. Ready? Mark set. Woo! Okay, here we go. When you come to a word problem, write the whole thing. No, just kidding. Write the important given information. Just start laughing. Start than crying. Write the important given information. So right now, I'm not going to make you write the table, even though maybe I should. But I do want you to write. Okay, write down examples. We're in the example part. What are we doing? We're doing the advertising problem. Okay, write down advertising. Period. There you go. Advertising problem. I guess I could have you write the table. I probably won't. That's kind of messy. I guess I could have you write the graph. Probably won't. But what do you think is important to write? All right. So go get that for me. S equals 9.3 e to the 0.1129 t between 11 and 15. And the nice thing is, oh, they're helping me know who is S, who is T. S is spending in billions. And T, well, 11 represents 2011. So when it says 11 to 15, what years are, 11, 12, 13, 14, 15. Does that make sense? Sometimes you have to go through quite a bit, but that's okay. That builds the problem and lets you know what you're doing. Not making you write the table, not making you write the scatter plot. You have it to refer to if you need it. You have the equation. What are they actually asking us to do with this online advertising? How much is being spent on online advertising? Look at the bottom. Go find the question mark. Oh. Go find the statement. According to this model, when will the amount of U.S. online advertising spending reach $80 billion? What do you do?
Well, since it's 80 billion and we know that S is spending in billions, we can just plug in 80.
And does this look like something that we're going to solve by hand? You could if you want to.
Okay.
Oh, I see. The whole chapter.
Solve for T. Now, we could use our graphing calculator. I probably will let you use your graphing calculator. We could graph this and actually graph one, graph the other, find the intersection. But we really want to work on our math. So we would divide 80 by 9.3, right? Why am I not writing billions? Because isn't billions what they're measured in? So we're good. How do they get rid of an E, guys? It's trapping my T. I can't get to them.
Let's natural.
Yeah, that's natural log. Good idea. Right? Then how do I solve for T? Divide. And for most of us, this little process, even though how it took a little bit of time? I'm dividing by 0.1129 to get t by itself. It was a lot faster than getting both of these put into our graphing calculator, figuring out our zoom and our fits and our outs and our ins in order to get a nice picture, and then finding the intersection. I bet this is probably faster. So as you guys are writing this down, I'm doing a calculator momentarily, don't worry. I'll give it back. 1 divided by 0.1129 times ln of 80 divided by 9.3. I'm getting an actual answer because I want you to help me interpret it. When it says 19.06, what on earth does that mean? 2019? And a little bit more, right? So when will it meet? Technically not at 2019. We could figure out days, months, years, blah, blah, blah. But let's just say somewhere between 2019 and 2020. If we want, we could figure out 0.06, etc. of a year, which would be 600ths of a year. Not even a month has gone by. So it's in the first month.
January 21st
Nice.
at 6 o'clock. 1.9.
Look at this guy showing off. All right. Does that kind of make sense? Huge problem. It came down to setting in model equal to 80. Okay. Remember next one. Oh, this was my work page. We didn't use it. Keep going. There we go. Situation.
Students. College.
College campus virus. Okay. College campus virus. Not that one. Oh, that one's quite dangerous as well. On a college campus of 5,000 students, one student returns from vacation with a contagious and long-lasting flu virus. This stuff actually happens. Take your vitamins in college and be wise. The spread of the virus is modeled by y equals 5,000 over 1 plus 4,999 e to the negative 0.8t. Can you guys real quick just look at your models? What model does this seem to be fitting under? A number on top, division, 1 plus a number e, logistic growth. Can we talk about this real quick? Why does this graph look the way it does?
Because there's going to be a ton of increase, but at some point it's going to have to burn out.
Viruses do grow exponentially, but the point is, if they quarantine the campus, which I think they do, the college campus will cancel classes when 40% or more of the students are infected. If they cancel the classes at a certain point and all the kids are in their dorm rooms and no one new is coming on campus, can this flu spread forever? No. It can only spread up to 5,000, and so it's going to level off at some point. That's how logistic growth works. It's realistic. It's exponentially growing for a while, but there's only so many people that can get infected, so then it's going to level out. Anyway, that's what's going on in that funny graph you showed. You guys wrote down the equation, yeah? This is what you would do in homework, true? College campus virus. Write down the equation. And then they tell us y is the total number of students infected. College will cancel classes when 40% or more are infected. Maybe some important stuff to write down or summarize. Letter A says, how many students are infected after 5 days? Okay, those in our equation, what stands for time? Bingo. So all we have to do for letter A is say, oh, easy cheesy. Find y of 5. Remember, not y times 5, y of 5. And where do I plug in the 5?
Missy, what's representing the 40%? Because that's going to be the limit. No.
Well, 40% is not the limit because that's when they're going to cancel classes and just let kids get better.
Oh.
The flu can still keep spreading in the hallways.
Yeah.
They're just quarantining, not letting people come on campus or go off. 5,000 over 1 plus, so they still hopefully they're quarantined. E to the negative 0.8 times 5. So basically what they're having us do is figure out, okay, 5 days have gone by, all these kids are getting sick. How many are we up to now? Anybody plug in and check it? I'll plug in and check it, you guys double check me, how's that? Or I'll double check you. In a good way. 5,000. You wish you had me double checking you on your test. 4999 e to the 0.8 times 5. Ready? 1, 2. What do you guys get? 54? No. 54.01? Nicole and I matched. Oh. Nice. I think I didn't round. 54.02. 2. Kids. So I guess it's 0.02. I think somebody just caught it, right? So maybe we'll see. We'll say it's somewhere between 54 and 55. 54 to 55. One kid has it and doesn't even know it yet. So that many students. But he will tomorrow. Okay. What's letter B ask? After how many days will the college cancel classes? Well, hold on. How do we know if maybe after 5 days? How do we know whether or not they're going to call it? They're going to cancel the classes. 40% of the kids have to be sick. Well, hold on. First of all, what is 40% of the kids?
Of 5,000.
You. Who likes decimals? Not me. Wouldn't that be 4 times 2 fifths? 2 fifths. 5 and 5,000 is 1,000 times 2 is 2,000. 2,000 kids have to get sick. I don't know how much time that takes. Sure wasn't 5 days. Who is 2,000? Who are the kids? What variable? Y equals 2,000. Solve for kids. Math this section 3.5. We'll do a few more examples tomorrow. Maybe go over a couple questions. We're starting on our review after that. So do as much homework tonight as you can. Bye, guys. You need pictures of the front. Please go ahead. They'll be gone by the end of today. Bye.